In this video, I'd like to talk about the network synchronization component as part of the UCNetwork library. This network synchronization component is responsible for keeping track of positions and orientations of any sort of networked objects, as well as maintaining unique identifiers for each networked game object. Let me show you what I mean. Over here, I have my example server. On the right, I'm going to go ahead and run that. On the left here, I'm going to run two things. One is a built client, and the second is just a version of the client here in the editor. And I'm going to connect both of these clients to my server. I'm connecting to the address 127.0.0.1, which is the local host, which essentially means my own machine. And so it's going to connect to the server. And there is my player object. And then over here, I'll do the same. Excellent. So here in the game, now that I have both clients connected, there are two player objects, which I'll show you just by moving one away from the center. And notice how when I move these things around, they are synchronized between both clients. In addition to the position being synchronized, the rotation is also synchronized. And both objects, can move around in this way. Now the question exists of who is responsible for sending the data of these new positions over the network? How quickly does it send this information? What information does it send? And how does the receiving client, once it gets this information, how does it know which game object to update when it receives these messages from the server? Keep in mind, remember that as I move this object around on this client here, this game object is sending network messages to the server, and then the server is relaying those messages back to my second client. And then my second client is responsible for updating that specific game object. So let's dig into this in a little more detail. Notice how I have two player objects here. Each of these player objects was instantiated by the client. One of the first things it does is it instantiates this network game object. This network game object is an instance of this player prefab here, which is part of the resources directory. On this player prefab, it's got a couple things, the box collider, a mesh renderer, but down here is the really important stuff, at least for the networking system. The first thing it has is a network sync, or a network synchronization component. This network synchronization component is responsible for maintaining a unique network ID, which is unique across all clients, meaning that if this game object here on the left has network ID 123, then over here on my other client, this object here will also have that unique ID 123. It's this network ID that is solely responsible for allowing us to know where messages should be going. So when the server gets a message saying object 123 has moved to a new position, it knows which game object in Unity we're actually talking about. The next thing that script has on it is the delivery method. Delivery methods support unreliable sequence or reliable ordered. This gets in a little bit of the guts on the messages that are being sent over the network, on whether or not we care if every single message arrives in the order in which we send it. Remember that typically when we're sending messages over the internet, they may be bouncing between a bunch of different data centers, off of different routers, various servers, through the web of the the giant network topology of the internet. And any of those messages can actually arrive out of order. So the question here is, do you want those things reliable and to arrive in order? The message is about the position and rotation. Or do you care if an old one shows up later than a newer one, can we just forget about it? Typically for something like position, if you receive a position update and then you receive another message that is old or was delayed for some reason, typically you don't care about the old position because you already have a newer one. So the default here is unreliable sequenced, meaning that these things are in order and they are unreliable, meaning that it's not actually confirming receipt of these messages, which reduces the overhead of the network messages in general. There's a broadcast frequency. This is the rate at which these messages are being sent. Remember, by default, it's just position orientation. Let's take a look at what this broadcast frequency does when it comes to one of the player objects that I'm actually moving around the scene. See how smoothly it's moving my player object on the right side? It's because it's sending position messages 10 times a second. That's what this broadcast frequency is. how often should we send these messages? 0.1 is 1 every 10th of a second. Let's go select the object that I have here. This is the player object on the right that I've selected now. If I change my broadcast frequency to something like 0.5 and then start moving around the screen, notice how jittery and choppy it is over here. This is quite literally what happens when you experience a high amount of latency or network lag, right? You're not sending positions as frequently as you used to be over the network. So other people looking at your objects or looking at your player, they're seeing you jump around because they're not getting position updates as frequently as you used to be sending them. We can make this even worse. We could say, send it once every 3 seconds. And now when I move around, only once every 3 seconds it'll send a message. Typically, somewhere around 0.1 is good for a relatively fast-paced, movement-based game like this. The last option we have here is this checkbox of in-area only, which this one is whether or not these messages are broadcast only to the areas the game object exists in. And for a little more detail on that, go watch the video about area filtering. So, the next script that's on here, this network interpolate. The network interpolate script is responsible for smoothing the motion of remote objects. Notice how if I look at the second player object, this is the player object here on the left. It's the remote player, the one that this client does not own and is not responsible for. As I move this around, the object is moving smoothly, even though I'm only getting position updates 10 times a second, right? If I were to disable this network interpolate, it's either going to break things or maybe it'll be jittery. Yeah, it's jittery. So this jitteriness, what it's showing us now is it's showing us the positions as I'm getting them over the network, right? For a little more detail on what this means, let me turn this back on and let's hop over to the scene view. In the scene view, this can give us a bunch more information. So let me line up my view so it's roughly equivalent to what my game view is like. So here's my 2 game objects, the one that I own here, and then the one that I'm getting remotely over the network. When I move this object around remotely, you can see all those spheres that are showing up. By default, here in the scene view, this will show you the 10 most recent position updates that we've received over the network, from the NetworkSync. These positions, these spheres here, are the positions that I'm getting over the network from my other client. My client on the right is sending these. So client on the left, the one here, this is responsible for smoothing the motion, because if it doesn't smooth the motion, you notice how there's just these individual discrete position updates that it's going to get. It's going to look jittery. It's going to look choppy. So there's actually a lot of discussion, a lot of information about interpolating these network positions that I really hope you dig into a lot more in the future. And various games tackle this in various different ways. And actually, the under the hood, Unity's physics simulation does something very similar to this as well. Because remember that physics simulations also have discrete update. They're not completely smooth like our gameplay updates. So let's take a little bit more look into the code behind the NetworkSync. Here's the NetworkSync component, which every single game object that is a network synchronization or a network synced object needs to have. Now, remember that the most important thing that this tracks is the unique network ID of the object. This is the biggest reason why every single network game object needs to have a network synchronization component. Without this unique network ID, everything sort of just falls apart. So, we wouldn't be able to send remote procedure calls to specific objects. We wouldn't know who or which object is being updated by various positions. This is the number one reason why we need this component, is to essentially track these unique IDs, these unique identifiers. The next thing a network synchronization component keeps track of is whether or not this client owns the object. And owning an object essentially deems who's responsible for sending the position of this thing. This is information that the server has as well. So you can imagine a case where this client over here attempts to move this object. Notice how I can't because I don't own this object. And actually, if I send position messages for this object to the server should deny my position updates. This is similar to if we were playing an online game and then I started telling the server where you are moving or where your player is moving. I don't own your player. I'm not responsible for that player object, so I shouldn't be allowed to. The ownership of a network object, if you're ever looking at this inside the Unity inspector, if you turn on the debug view here by going to debug, this will show you whether or not you own this object. There's a Boolean field here that's checked on or off. You can also see how much time is remaining before it sends another message, and a couple other neat things in here, including the area IDs that the objects are within. Right? Excellent. Next, here's that delivery method that we're talking about, the broadcast frequency, the in-area only values. And then there's a couple things here about getting synchronization data and setting synchronization data. I'll talk about that in another video. The position, rotation, as well as this original scene. The original scene value you can kind of ignore for now. This is for objects which are networked objects which are placed in a scene. The position and rotation here are the values that it's actually sending and receiving over the network. It pulls this data from the object's transform information, which we'll see in a minute once I get down there. As this object moves around, let's hop down to that code. As this object moves around, the update function, because this is just a regular Unity component, the update function gets called. This time to send decreases based on how much delta time has passed, and then eventually we hit that broadcast frequency value, and then we call this function called broadcast sync, or broadcast the synchronization message. When we broadcast the synchronization message, first we check, is this an object I actually own, just to verify this. And then we gather up a bunch of data that we should be sending about this object, which typically includes the position and rotation of the game object. We then determine whether or not we can send a light synchronization message or a regular synchronization message. And then eventually we send this off over the network. And you can see this by these function calls here. It asks the client network to either send a synchronization message or to send a light synchronization message. The difference between a light synchronization and a regular synchronization is that the light synchronization only sends position and orientation. That's it. It doesn't send any other information. One of the features is that we can add additional data into the synchronization messages that are being sent over the network along with this object that get broadcast 10 times a second. As I mentioned earlier, check out the next video about synchronization data to explore that in a little more detail. Network objects also have a couple convenience functions, adding them to an area, removing them from an area. Here's the code for drawing those gizmos that we looked at in the scene. The last thing is calling an RPC. To call an RPC directly on a game object that has a network synchronization on it, instead of using the call RPC function that's defined in the client network, you can use this version of the call RPC function, which is one that's defined in the network synchronization component. So in my game scripts, I could go grab this network object, get the network sync component from the network object, and then use this function here, call RPC, to call a remote procedure call that exists in a script side by side with the network sync component. This could potentially call a network sync on this player script. Let's take a look at this player script real quick. Right now it's just an update function, but I could add additional functionality here, additional remote procedure calls, which could then be called directly through the network sync component. And in that way, I don't need to worry about specifying a network ID or things along those lines. I hope this video has given you a general overview of exactly what the network synchronization component does, how it functions, as well as the various methods that it provides for us and the very important role that it plays in the overall networking system.